right, hello, Algebra 2. This is lesson 10.3, exponential one-to-one property. I will be able to solve exponential equations. These are simple exponential equations using the one-to-one property, which relies heavily on exponent properties. So we have, for example, some base to a power of m times a base to a power of m. When things have the same base, it allows us to just add the exponents. So the base stays the same, and then we can add m plus n. So for example, x to the 8th times x to the 9th would be x to the 8 plus 9, or 17. So all we have to do is add the exponents in a product. Here we have a base raised to a power raised to a power. So we call this a power to a power. And when we have a power to a power, we multiply the powers. And so the base stays the same, and then we just multiply m times n, or just write mn. So again, if we have x to the 3rd to the 5th power, then the base stays the same, and we just multiply 3 times 5. 3 times 5 is 15. And here we have the negative exponent property. Negative exponents just make things move to a denominator. Move it. And conversely, if it's in the denominator, it makes it move up. So this just becomes 1 over b to the m. So move it down. But if you have like 1 over b to the negative m, then again, that negative exponent just says, hey, move it up. So it just becomes b to the happy m, okay? So quick review of exponential properties. And now we're going to tackle solving exponential equations. So again, we want to solve using the one-to-one property. And the one-to-one property is right here. That says, if the bases match, if you can rewrite your equation so that the bases are the same, then u is just going to equal v. If the bases match, then the exponents must match. And you can solve that way a lot. First of all, these are exponential equations. There's an I in there, exponential equations, because the x is in the exponent, makes it exponential. So this is one method. The one-to-one property is one method for solving exponentials. And you can see I'm going to use this method because 8 and 32 are both powers of 2. So what I'm going to do is I am going to take the 32, and I'm going to take the 8, and I'm going to rewrite. All right, we're going to rewrite them as a power of 2. So 8, well, 8 is the same as 2 cubed. And again, you could test on your calculator. 2 to the 3rd power is 8. All right. And I didn't change the exponent. All I did was rewrite the base just a little bit. Then we have the equal sign. And again, I'm going to rewrite 32. What is 32? Well, I know 2 to the 3rd is 8. What's 2 to the 4th? 16. 2 to the 5th? 32. So I'm going to replace 32 with 2 to the 5th. And again, I'm not changing, that's a 5. 2 to the 5th. I'm not changing my power right now. I'm just rewriting it so that we get the same base, because our goal is same base. All right, base. All right, so we have the same base, and now you can see what's happening here. We have our power raised to a power. So this is a power to a power, and we need to simplify. So we're going to multiply our powers. And that would be distribute. So again, our base is 2, and now our power becomes 5 times 3x is 15x, and 5 times negative 3 is negative 15. And again, our base stays the same, base of 2. And then we have 3 times x is 3x, and 3 times -1 is -3. Now, if the bases match, which they do, then u must equal v. U must equal v. 15x minus 15 must equal 3x minus 3. And then we can just solve for x. And it's so easy. So I'm going to go ahead and subtract 3x. So that gives me 12x minus 15 equals -3. I can go ahead and add 15. Of course, you can not show these steps. So 12x equals 12, and we can divide by 12 and get x equals 1. And that is fantastic. All right, easy to solve. So I do want to show you in the calculator. Let's see if we can see this in the calculator. 32, 3x minus 3 equals 8 to the x minus 1. So what we're going to do in our calculator is we're going to put the left-hand side in y1 and the right-hand side in y2. And remember, you can always solve equations this way. So that's why I teach this, because it's the best way. Well, it's not the best way, but it's definitely a good way. So up in your exponent. Now, if you had a Casio, you'd need your exponent in parentheses. So I'm just going to do that. You don't need it on the TI, but you do if you have a Casio. X minus 1. So I'm just modeling it with parentheses. And I'm just going to do zoom standard and see what we see. So there's the first equation. Now it is a Superman shaped graph. Doesn't look like it, but it is. There we go. And what they're doing is they're intersecting right here. I'm going to change the window. And I just need right around here from like 0 to 2. And I'm going to change my window. My x-axis, I'm going to go 0 to 2. And my y-axis, I'm going to go 0 to 2. Just so I can get real close to see what's happening. So there's 32 to the 3x minus 3, and here's our 8. There we go. Look at that. There's our point of intersection. And we can then calculate the intersection. And so in a second, calculate the intersection number 5. And first curve, you're just going to move Tinkerbell right to that intersection point and go enter, enter, enter. And on the Casio, you do G solve and then intersect, and it's super easy. And so you can see there's our solution for x, and that's what we solved for. Okay, so we can check and see that x equals 1, and that matches our solution. So that's one way to do it. Okay, same thing here. The first thing I'm going to do is start by rewriting so that we get the same base. We need the same base. So that's step 1. Now, 216 is pretty tricky, but I think it's a multiple, it's a power of 6, right? So think about rewriting this base as a power of 6. All right, so let's see. 6 to the second would be 36, and 6 cubed is 216. So 216 is really 6 to the third power. Again, I haven't changed my exponent yet. All right, now this one is a fraction. And so I'm going to make my exponent negative. Let's see what, this is 279,936. Again, I'm hoping it's a power of 6. Let's see, what's 6 to the 4th? 12. 6 to the 5th? 7. Okay, 6 to the 6th. 46, 656. Still bigger. What is 6 to the 7th? Oh, there we have our winner. 6 to the 7th. So 6 to the 7th power. Now that would be just 27,966. Watch. 6 to the negative 7th gives me a crazy number, but I can math frac it, and you can see, whoops, it didn't like that. Oh, funny. That was too big to math frac. Craziness. But 6 to the negative 7th would give me that fraction, okay? So 6 to the 7th gives me 279,936. And if it was negative exponent, that would just be 1 over that value. So we have a negative 7 there to create that fraction. And again, I haven't changed negative x minus 2. So now we can go ahead and multiply our powers because we have a power raised to a power. So let's rewrite that. So we have base of 6. This becomes negative 15x plus 30. And a base of 6, negative 7 times negative x is 7x. And then a positive 14. So if the bases match, then our exponents must match. So negative 15x plus 30 must equal 7x plus 14. Then we can just go ahead and solve for x. I'm going to go ahead and add 15 over here. That would give me 22 x's. And I'm going to subtract 14. Is that 16? Must be. Yeah. Okay, and I can go ahead and divide by 22. And I hope I got that right. And we reduce. So you would need to reduce this fraction. I can divide top and bottom by 2. So 8 over 11. Hopefully that's right. You can always plug the value back in or do the graphing method to double check your answer. Let's try a couple more. This is all we're doing today. Pretty nice. So again, the first thing I want to do is think about rewriting these bases. Again, I see 1 over, so I think I'm going to have a negative exponent to create that fraction. And again, 1 over, negative exponent, because it's 1 over. So let's see, 4096. Or did we do that with 6's? 6 to the 3rd? 6 to the 4th? 6 to the 5th? No, 4096. Let me think. I'm going to test some other numbers here. So it really does help to know your powers. 4 times 4 is 16. So I thought that maybe something with a power of 4 would give me a 6 in the ones position there. So these are powers of 4. And so you can see that 4 to the 6th was 4096. So 1 over 4096 would be 4 to the negative 6th power. And again, I'm not changing my exponent yet, negative 2x plus 14. All right, and so now we need to figure out how to get 32,768. So again, I don't have all of these memorized. So 4 to the 8th. Oh, interesting. I'm too big now. Oh, so maybe these aren't powers of 4, but powers of 2. So this would be 2 to the negative 12th. Let's test. 2 to the negative 12th. Oh dear. Let me just do 2 to the 12th. 4096. Yep. So this would be 2 squared, or 2 to the negative 12th. Just kidding. Powers of 2. So negative 2x plus 14. Okay. So 4s didn't work because we got too big here. So let's try powers of 2. It's got to be bigger than 12. So 2 to the 13th. Nope. 2 to the 14th. 16. No, almost there. 2 to the 15th. 32,768. There we go. So that would be 2 to the negative 15 would give me 1 over 32,768. To negative 5x plus 10. Okay, so now we can go ahead and multiply our powers. So we have 2 to the, let's see, negative 5 times 15 is 75, I think. I'm going to double check. Yeah. And then minus 150, it looks like, equals a base of 2. And our powers, 2 times 12 is 24 x's. Oh, wrong color. 24 x's. Oh, I don't know 12 times 14. Using my calculator there. That gives me negative 168. So if the bases match, then my exponents should match. 75x minus 150 is equal to 24x minus 168. So I'm going to move my 24 over. So 75 minus 24 x's is 51 x's. And I'm going to add 150. And that gives me negative 18. And then I can go ahead and divide by 51. If you wanted to, just want to remind you that you do have the math frac, convert to a fraction on your calculator. So 18 divided by 51, crazy decimal. But if you math and then convert to a fraction, you get 6 over 17. So divided by 3, so negative 6 over 17. So I went ahead and checked my answer. And so all I did was take this value and plug it back in for x on the left, and I plugged it back in for x on the right. So this is my first equation here. That's the left-hand side. You can see I put my fraction in parentheses and then did a caret, and then just use parentheses to enter that equation in there. And then this is my second equation. This is the right-hand side. So again, 1 over 40, 96, and then caret with all that stuff in the exponent there. And you can see that the left side value is equivalent to the right side value. So they are equal to one another. All right, let's try this one. This one is quadratic. All right, so I have a base of 7 here. I can't rewrite that. It's already a prime number, so it doesn't change. So I'm hoping that I can rewrite 343 as a power of 7, and that is 7 cubed. So 7 cubed, whoops, there we go. 7 cubed is 343. And so to get 1 over 343, that'd be 7 to the negative 3 power. So now these have the same base. So, we need to distribute. I'm going to go ahead and distribute that. So that is 6x plus 12. It's equal to 7 to the 2x squared plus 4x. And now, since the bases match, our exponents must match. So 6x plus 12 is equal to 2x squared plus 4x. And now this is quadratic because it's got x to the power of 2, it's squared, okay? Which means we need to set it equal to 0. So I'm going to move all this over to the right-hand side. So I have 2x's squared. That's going to be, I'm going to subtract 6x and subtract 12. So that gives me 4x minus 6x is negative 2x, and then the minus 12. Now I can divide all of it by 2 just to make the problem easier. So that gives me x squared minus x minus 6. And now we can factor and solve. So I'm going to go ahead and double bubble. So x times x is x squared. What times what is negative 6? Negative 3 times positive 2. And then you would get x equals positive 3 and x equals negative 2 as solutions. Now, possible solutions. So I'm going to go ahead and take a second, and I'm going to start by plugging in x equals 3. Actually, I'll just show you how I'm doing this. So I'm typing in 1 over 343, caret, and then this would be negative 2 quantity. In place of x, we're plugging in a 3, and then minus 4. Now, if you had a Casio, you'd need parentheses around that whole exponent. And so there's our left-hand side. Now I'm going to plug 3 in here on the right-hand side. So that'd be 7 to the 2 quantity 3 squared plus 4 quantity 3. There we go, all in the exponent. And again, those both match. So we know that is definitely a solution. Now I'm going to do the same thing plugging in negative 2. And again, use parentheses when you're plugging in for x. So we have negative 2 quantity, negative 2 minus 4. And now I'm plugging into the right-hand side, 7 caret. We have 2 quantity, negative 2 squared. So again, that has to be in parentheses or you're not going to, your calculator won't be doing things correctly. And 4 quantity, negative 2. And they both equal 1. So both of these are true solutions, okay? They both work just fine, so it's a good idea to check your answer. And I think that's fine, ladies and gentlemen. Your Delta Math 10.3 should be good to go. Let me know if you have any questions.